Alright, should be recording, better check. A little bit of issue here and there now and then. Alright, Hythloday has made another video. I don't know whether he saw the previous video or not, but it doesn't really matter, I suppose. So, I've only watched half of it, and okay, so yeah, we just have to go right to this beginning again and just go through this, I suppose. And then I guess I'll go through it, and then you'll see the context of his curiosities. I think I've made it clear over and over again that all the electrons are the same, except the fact that they can have a different momentum, which means the boat's the same, but the rowers in the boat are different. So, yeah, clearly, electron going this way has rowers going that way. Electron going this way has rowers going that way, but they all have the same mass. So they're always carrying the same amount of stuff. And the reason why you need them to carry stuff, so let's just understand what's going on here again. So the force is always the same, right? So the arrows all have an equal amount of power, okay? They're all the same. And then we're saying that these matter bits, you know, the matter entity, the electrons and the protons, are conduits, which essentially allow a force to affect a force, in the sense that as this thing moves into different positions, all right, it will allow two forces to increase their pressure in their world. So if it reflects when it's in this position, it means that this arrow is going to take longer to get to reflect, so to speak, and get all the way back to this point. So in a sense, it's going to be weaker because it'll take more time to go back and forth. And this arrow, obviously, depending on what it's next to, is going to take less time if it's in this position. Or if it's in this position, the exact opposite would happen. So obviously, this thing moving is going to affect the worlds that are going to be experiencing what it's doing. So everything is being experienced, okay, by stuff. And it's how that stuff experiences what's going on is, you know, what we're talking about here. Because it's going to now reflect more. It's going to change how it behaves. And that's how everything's interacting. That's how everything is connected to everything, is through how things move. So the problem would be is if, let's say I just said this, that the force bits have all the mass, all right, and they have all a mass of 1. And so it really just has to do with how much of this stuff there is, and that's mass. It's just the momentum is all just force, and this has no momentum, but this just moves around. Well, the problem would be if I give this no momentum, if I give it no mass, if I don't put rowers in the boat, you know, if I don't put force in here riding in it, then this, when force bit hits it, it moves the speed of light. Or one force bit hits it this way, the whole thing, the electron ends up moving the speed of light. And I don't think that's what's happening. I don't think that can fit. So I think you have to give this thing some mass. So I would equate it to, like the gravity argument, the Earth is at equilibrium as a piece of energy. So even though it's got a bunch of thermal energy in the inside, molten stuff, all kinds of stuff, it's at equilibrium. The same amount of stuff goes in as the amount of stuff going out. Okay, because it's achieved, it's a full battery. But it is a battery. So it has capacity to give at any one moment, at any certain time, it could give the universe a lot of thermal energy. It could expel more. All right, it has the potential to give up more energy, or it has the potential to absorb more energy. So it has built into it a mechanism that allows it to change its temperature. By having a temperature, by having its own cushion, its own amount of temperature, it's allowed to fluctuate, to absorb more or to irradiate more. And sort of that's what the Earth is doing in this slow process of global warming. You could argue that the Earth is going to become a net consumer of a little bit more energy. It's going to break its equilibrium a little bit in the direction of absorption and become hotter. And then it'll achieve a new equilibrium at that higher temperature. because of the carbon we put in the atmosphere, blah, 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 blah. All right, so the argument is to understand that the electrons, yes, they're all the same, and just for the sake of argument, you can make up any arbitrary number, but the number would be as I tried to explain with Velcro arguments. See, I can only use analogies. I don't have anything else but analogistic things, because that's all you can do. I can't show you the actual function. I can just show you how it works like. So let's just say it's like a clock or something. It has 12 empty seats, okay? There are 12 seats. They're not empty. And the point would be is that through interactions with the universe, this electron will achieve an equilibrium. And it will constantly be effectively neutralized every, 5 seconds. Because the energy that comes in is constantly making exchanges. So any imbalances that might be in these seats, that's right. So if these are all arrows, that if everyone in these seats is, it's always something. Some cunt Angela from the warranty department, I'm sure. The ambiguous warranty. Oh, do I get a life warranty? Is that the department? I should have held on, but it was a recording. They're no fun. Can't really play with a recording much. All right. So the point is that this energy comes in, and essentially, if all these things were moving in the same direction, you could sort of understand that when the exchanges are happening, it's going to be having exchanges with all these directions, and so everything's going to be turned back into an even amount. They'll have just as much stuff going this way as going that way, as going this way as going that way. So electrons are, the external pressure is constantly sort of telling electrons, if you have any momentum, I'm going to take it away from you eventually. Okay, I'm going to neutralize it because of the laws of probability. Okay, because the external pressure is going to tend to be even, and it's going to tend to force the electron to equalize to the environment it's in. I mean, this is this is something you have to understand about what achieving thermal equilibrium and all those kind of concepts are, but this is the same kind of concept, okay? It's not really critical that you understand this, to understand the basic ideas involved, beyond understanding that this allows things to have a cushion and allows things to have a history. Okay, and electrons clearly have a history. That's the whole point of them talking about spin. That's really just talking about their previous conditions, what they were doing a second ago, because that is going to have an effect on what kind of force they're going to emit when they start to decelerate or slow down, or more importantly, balance. Slowing down sort of just means balancing to the environment. If you're moving, you're imbalanced to the environment. You're doing something against the environment, something almost hostile to the equilibrium of the environment. And the environment will tend to take that away from you. If you're an electron or a proton, if you're more than an electron and a proton, then you can have a mechanism to fight against that. But I don't want to get into the drag argument. Oh, damn. All right, so Hythloday is thinking about this stuff and says, okay, so now he'll use an example of, some idea of using size to represent speed or momentum. And it's just a bad idea. Let's not get into it, because there's no size difference. But let's just say this thing's going twice as fast as this thing, and they hit each other. He has this assumption that somehow I'm arguing that the 2 reflects as a 2, and the 1 reflects as a 1. And that doesn't happen. As I've pointed out, this is the whole way electricity actually works. Electricity works by saying you have a row of atoms, and they're all, let's say they're all 2s, and quite happy to be 2s, all right, and you show up, let's say they're 1s, okay, and all happy to be 1s, and then all of a sudden I pump this one up to a 3. Well, the idea is that this one next to it is a 1. Well, both of them will become 2s. All right? And then now this one's a 1. And now both of these will become 1.5s. And now this one next to it's still a 1, so this one will become 1 1.25, and then 1.25. You see, that's the way it works. And so any pressure here just keeps getting balanced to its neighbor. So they're all going to be the same pressure eventually. Eventually. Because there's always going to be an imbalance between neighbors. As this one transitions, so this one's a 3 and this one's a 2, and so they become, no, this one was a 1. So they become a 2. And then when this one and this one cut that into a 1.5, obviously the 2 and the 1.5 are now not balanced. So they'll rebalance again to a 1.25. So as you balance one, you unbalance the other pair. So as I become balanced to this, I'll unbalance this. And then as I balance this, I'll unbalance this. And it just keeps going that way. And it all is linear in a direction, in the sense that you're going to go from the 3 to some kind of 0.75 in the end. You know, so whatever the thing is, the lowest. But again, you have to have a drain. If you're going to pump it in here, you have to have somewhere for it to pump out. So obviously the circuit has to be connected to a ground or to a negative or to something that allows the high pressure to go to a low pressure. And as soon as I turn that off, I block that, then they'll all just pump up to 3s. Okay. Alright, so the important context here is to understand the electrons are all the same. They have the same number of seats in their boats. And all that you're really doing is giving yourself, this is a ping pong paddle, okay? So it's a little more complicated than just a regular ping pong paddle. But the idea is when the little new ball hits it, all right, it makes an exchange. That is, this ball jumps into a seat going this way, and this paddle releases a ball going this way. All right, this one doesn't reflect. It gets absorbed, takes a seat, makes the paddle now want to move in this direction, all right, and it gives back this one. So in a sense, it's made a 2-ball exchange. I mean, it's gone from having an imbalance this way to having an imbalance this way. It gave up this direction and kept this direction. So it's more than just keeping a direction, you're exchanging it for the opposite direction, which is part of the key to the whole thing. So the paddle moves in this direction. Obviously, if there's another paddle here, that means these balls bounce quicker, which means more exchanges are happening doing the same thing. And so when this ball goes this way, it's going to cause it to do exactly the opposite, move in exactly the opposite direction. So the exchanges keep happening, and whatever side has more balls is the side that's going to win in the end. More impacts means you're going to end up making the boat move in that direction. That side's going to win. New positions will be achieved, and essentially the pressure that was in this stream, okay, will essentially, through the paddle, through jumping through these seats, will eventually jump into this stream. So if you have 500 balls over here, you will slowly but surely bring them into this stream over here, and now you'll have 300 and 300 instead of a 500 to 400. So it just ends up balancing. So every scale, so you go from the electrons, and then you go from the atoms, and then you go from the molecules, and then you go from the piece of plastic. At every level, essentially the same thing is happening, is you're just equalizing the pressure, and it gets equalized through the medium of the little boats with the little pressure bits, the paddlers, the ping pong balls that you held, that you possess. And through exchanging those through the medium of the ping pong paddle, okay, the paddle doesn't just reflect, the paddle eats the ball going this way, holds on to it, and it gives up a ball going this way. So it looks like a reflection, but it isn't really a reflection. It's a guy changing seats. And by changing seats, he can change sides. Once he jumps onto the boat, now he can jump off the boat on the other side of the boat. And then he can jump into another boat. And then he can jump into another boat. And then he can jump into another boat. So the way the force gets from one place to another is to jump into the boat and then jump out of the boat on the other side of the boat. And then he can jump into the other boat. And then he can jump into the other boat. And he can jump into the other boat. So the force needs the boats to get to the other places. As pressure. Let's see how else to say it. I mean, obviously it'd be nice if the force just went where it was going, and that would simplify everything. But obviously, as I've explained, the force can't interact with the force that way. So the only way we can have these interactions is to create the boats in the way, to slow the whole thing down. It's the only way you can create matter and traps and all that stuff. Alright, so we'll play his videos and see if there's any other point I need to emphasize. But I think that sort of covers it. It's kind of sloppy drawing. I wasted a lot of paper. Yeah. Oh, horrible. Wasting crappy paper. Anyway. Mouse. So, like I said, I would like to just say the matter is nothing. Matter's just a piece of paper that allows things to bounce off of it and reflect, and then paper just moves with the reflections. But we know it's a little more complicated because the paper doesn't move the speed of light. It has to be incrementally increased in its momentum, and it incrementally decreases in momentum. That's how photons are created. That's why photons are at a frequency, is because of the incremental decline in the speed of an electron.
When I did my two bodies discussion, I meant bodies, I didn't mean atoms per se. But what followed was
Right, so he didn't mean atoms per se. I thought at one time he was meaning electrons per se. So, you know, again, I'm not doing this body thing. I just don't want to play body crap, okay? All of them aren't the same. The elemental bits is the real universe, so we probably should just stick to electrons and protons and just understand that whatever an atom's doing, it's only doing it because the electrons and protons are doing their thing. They're the fish. The school is just an extension of what the fish are doing. So if you can understand what the fish are doing, you don't have to worry about what the school are doing, and you don't have to worry about the schools, and you don't have to worry about the herds, and you don't have to worry about any of the bigger stuff, because you understand the little stuff is what made it do it.
a happy explanation of how, with the added complexity granted, and not gone into, but that's fine, the added complexity of polarization, accepting that it's a kind of Lesage force which causes repulsion, only in the inverse, in the opposite way, in which gravity only attracts. But
again, it is just pressure, and the catch is that reflection is really important. So obviously reflection is the major function of all of these things, because they really don't have much holding capacity. They only have 12 seats on their boats, so they can't do much else but reflect the world that hits them, except for the little cushion that is their little bit of change they can impose. The 12 extra seats they can change.
I still hate it every time you say the rowing business. I'm wondering now whether, in your theory, that working under the assumption are electrons of necessarily of different sizes.
Well, again, I think I've made it very clear over time that, of course, I don't think so. I think they're elemental. It's all the same stuff. And clearly, if they were different sizes, that would mean, you know, most of the experiments would demonstrate that somewhere. We would see the slow electrons, the big fat electrons, and then we'd see the skinny little fast electrons. We don't see any of that.
So it's too complex to imagine a complete body. It was quite satisfactory for for the context about how you explained how forces are transmitted through a body. That was quite good. but it's still not getting at the mental problem that I perceive. So let us stick with the two bodies of an electron. And I'm trying to say is, well, firstly, let's check our understanding here, my understanding. Are we saying that electrons are of variable size, firstly? Because when I talk, I will tend to, maybe mistakenly, talk about, as orthodox physics will always take them as the same size, and of the same, well,
clearly I'm saying they're the same size. Clearly, if they have momentum and they're excreting a force, okay, all that can possibly change is sort of a relativity argument, right? I mean, to the electrons, they can't really tell whether I moved into you or you moved into me. All they care about is how much force is going to be created. So the faster they're moving, whether one's moving 10,000 miles an hour and one's only moving 1 mile an hour, it doesn't really matter to the electrons or the atoms, because all they're going to say is, what's the average of that in the end? They're just going to cut it in half. So they're going to say it's 11,000 miles an hour, cut it in half, and both of them are going to pressurize, so to speak, to 6,000. Or, you know, whatever they're both going to pressurize to the mean of that number. 10,500.
Charge means something for them that it doesn't seem to mean in quite the same way in DraftScience's particular model.
Well, charge doesn't mean anything to them, so there's no point in you saying anything about it because they have no clue how it works. Again, they don't give you any explanation why two charges attract or two charges repel. They don't account for any force, any mechanism whatsoever. They just vaguely say something like a virtual photon, and they say Maxwell has some lines, and that's it. They don't give you any indication where the energy comes from or how it gets there or how the two things move. They have absolutely nothing. I've given you quite a lot of detail about exactly why they move and how they move.
So, you see, I have a problem that I want to speak as orthodox. I don't want to. I mean, I'm trained in it. Yeah. So it's my neurological inclination to say, like to me, I was like watching it, and I was going, oh yeah, this is great. Two electrons. Yeah, the Lesage system, only with polarity, causes, you know, the tension increase is fine, and we get a repulsion. But I'm asking myself, this mechanical description. Why don't the two electrons that never touch, why don't they always bounce back from each other? See,
they do, and they bounce back from each other in a very even way. So that even makes it even understandable in thermodynamics. Like I say, in the thermodynamics of gases, and why it all ends up neutralizing to equilibrium eventually, is because each interaction ends up with the two averaging the interaction. So they're all they believe in relativity, okay? So they're relativists. They're saying, I don't care which one of us is moving. I don't care which one of us is madder or hotter or more irritated. The point's going to be when those two atoms hit each other, what they're basically going to do is just sit there and say, let's just split the difference, okay? You're black, I'm white, let's become gray. And they both leave gray.
I don't think, if they're the same size, the Lesage force, and you kind of imagine them floating very gently, they will bounce away from each other. But what I'm missing about the electron is what it really means for this to be going twice the speed. So this going twice that speed, this going once that speed, 1 unit, 1 meter per second, 2 meters per second, boom. This one goes back. I don't think we've really explained how the, let's say, unnatural tension occurs to make sure that it's this one that bounces away. Yeah,
there is no making sure. There's no need to make sure. There's no obligation. It'll be dictated by the fact that if I'm connected to a bunch of other CDs, all right, and you're an individual CD, Well, then obviously, when we do the exchange, we're both going to do the gray thing. Okay, we're both going to sit there and have the difference of the force. All right, but you're clearly the one going to be leaving. I'm not going to be going anywhere because my grayness is going to be spread to all my fellow mates. So I'm not going to go nearly as gray. Okay, I'll only be going gray for a split second. When the interaction happens, I'll go gray. And then I'm going to spread the gray against all my white or all my black friends. I'm going to bleed it, you know, like ink. I'm going to ink all of them, and I'm going to go back to almost my original color, while you're going to stay gray and go in a gray direction at a gray speed, because you don't have anything to share it with. So that's the only difference. If you take two individuals and make them into the circumstance, yes, you'll take something that's black and something that's white, and they'll turn gray.
I know it's elastic and it's a pull, but you kind of get there's an equalness in that tension of an elastic band. And orthodox physics would say, yes, if I had two different sized, a cannonball and a small cannonball, yeah, the small cannonball would pull quicker because we would say they both experience the same force, but this is an abstract thing, not in the way.
Well, again, you have to use a metaphor that you can qualify to the circumstance. You can make it have the same properties. So you have to create some condition of understanding that these cannonballs have an elasticity. That is, they have a force field around them. And the force field's proportional to their size. Let's say inversely proportional. And so that's the equalizing force, right? Because the big cannonball has a more smushable surface than the small cannonball, so it'll bounce it back, blah, 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 blah. But that's what's going to equal it out in the end. So the point is they're not really made out of lead, they're not made out of steel, they're not material things with had different masses and all this kind of crap. So I've clearly stated, electrons don't have a different mass, they just have mass in different directions. Mass is directional. Maybe that's one of these little things I should write down. Yes, mass is directional. Okay, that's something physics didn't figure out. Mass is directional. Okay. I mean, that's a way of understanding why it's the same thing as momentum, right? Because it's directional.
DraftSciences, they both experience the same force, but they would abstract it by saying F equals ma by Newton's law.
Okay, now again, I think you understand that F equals ma wasn't meant to be applied to electrons and protons, right? I mean, I think you kind of would understand that, right? That the F equals ma thing was sort of made up to describe how these big things are functioning, but there's no kind of reason. It's like the inverse square law. You know, it's not explicitly going to be the same truth for subnuclear particles, right? Because the world is a little different. The bits, the ping pong balls and the paddles are a much different size, you know? They're real ping pong balls on the nuclear level, where they're just bizarre little floaty abstractions on the big scale. So I don't know if you can really do that kind of thing. And again, what a mass is completely a fudgeable concept anyway. Okay, acceleration's pretty explicit, but mass isn't so explicit. And certainly the F isn't explicit at all.
Force equals mass times acceleration, and because this has the smaller mass for the same force, it experiences more acceleration, and this doesn't. But that's the maths. Yeah, there's no mechanics in that. There's just a jump to F equals ma. No.
Right. Well, even if you kept your broken analogy of having uneven sizes or uneven weights, I'm still going to argue to you, okay, that in the end, it just turns gray.
You, trying to sort of Lesage this shit, don't get to jump to F equals ma. You've explained quite well that how Lesage can cause them to experience the force, but it begs the question: are they necessarily different sizes? And what does it mean?
They're never a different size, and all you're really changing is their mass, in the sense that if mass is directional, then you can understand it in that form. But I'm just saying all you really have to understand is there's a total amount of energy that's going to be exchanged by them. If this one's, you know, how fast this one's moving in just means how fast is the force getting to the other object. It's still the same force, because obviously the force bits are only moving the speed of light. So we're just talking about really compressing the reflection. And whether this object compressed the reflection or this object compressed the reflection is completely irrelevant. So this is where you just take the relativity theory and you say, it just doesn't matter who accelerated into who. All you're having is the pressure, and now the pressure will be equalized over the objects.
Along for this to go two times the speed of light, and for 2 meters per second, 1 meter per second, or 0, 2 meters per second, 2 meters per second, tick tock, Newton, but they don't actually touch. Remember, this is how is it balanced? Why is it balanced? All
right, so let's go back to the boat example. You have 2 boats coming into each other, and as I pointed out, what's really going to happen is they're radiating force, and the force they're radiating is these little paddlers, the bits, the force bits. And the interaction is really going to be is that now as you're compressing, as they're getting closer together, there's more people jumping out of the water into the boat, right? If you want to look at it that way. Or more importantly, one guy jumps in this guy's boat. Another guy leaves that boat at the same time, right? So it's an exchange. So now the other boat, guy jumps in, another guy jumps out. Obviously, the closer the boats get, the more that's happening. So you got to be able to get the idea that more people are jumping in the boats, okay, in both boats. So obviously the boats have to, at some point, start moving away, because more are jumping in this way than are jumping in this way or any other way. This is where the most of them are jumping in, is this way. So that's the pressure. Pressure dictates which way things are going to move.
If you like, the tension coming from this one, stationary, exactly sends enough rowers, to use your speak, I guess, to this one that this stops, and this one exactly sends enough rowers over to this one to make this go 2 times faster. Yeah. Now, what you described as a Lesage effect is a simple. Any orthodox physicist could recognise that and say, "Oh yeah, well now we can use Newton." What you've described is a artificial gravity, artificial magnetism, wherein this body experiences this force, this body experiences this force, and they'd run away and use Newton's F equals ma. But you're missing that. Yeah, I think the crux.
I don't think there's nothing missing. Okay, I mean, it's just that I have to use the analogies we have, the force things in the higher level universe, the ones we see. So I can't make you the perfect drawing of it, except to make it as simple as possible. There are elements, little elements of momentum, and the electron is able to possess a certain number of them. 1,500,000. Who knows what the number is? I mean, the number has to do with how much momentum one photon could impose. One quanta of a photon could impose on an electron. Well, we don't really know that. And even when they measure things like protons, you're saying, well, when they measure the mass of the proton, what are they using to measure it? Because if they're using light, photons, we know that photons are made out of the energy that moves electrons, right? It's the reflective energy, substantially. So maybe that's kind of silly, right? Because that's not the energy that can move a proton. See, they think the photon is neutral energy. It doesn't have any polarization. See? So they could be making a huge mistake in the sense of thinking, oh, protons are much heavier because they seem so hard to move. Well, they're hard to move because you're moving them with a force they're invisible to. So yeah, that's why it's hard to move them.
May well be down to the only way to solve it might be to understand mathematically why the Lesage effect creates an inverse square law as well.
Well, again, I don't even want to get into this Lesage effect. I mean, you're just going to complicate things. We're just talking about the fact that we know a random pressure, okay, even random pressure, will cause spherical symmetry. Every single point. I could go to every single point in a random field, and all the energy that hits that point will be radial lines, equal length vectors of force. It will be spherical. So everything will tend, as it gets big enough, to go spherical. So that symmetry argument is inescapable, in my opinion. So if you just accept the fact that the big field is perfectly evenly random, why things go spherical and why there's an inverse square law is quite obvious. Obviously, the inverse square law breaks down, and as I pointed out, even Maxwell's equations concede the breakdown when you get very close to a magnet, for example. Okay, it goes from r cubed to r squared when you're very close to the surface of the magnet. And then it might even go to r, very, very close to the charge. You know, the north side of the magnet or the south side. So, you know, I just, it's okay. You want to say Lesage, it's okay. I'm just saying, clearly, it's not what I based my theory on. I didn't even know the guy existed when I started this. So I really don't want to rewrite Lesage theory.
See, you've not argued it. I don't know how to derive it offhand, except for the analogy about impacts. Yeah, that's the way you explain it. But don't you? You know, you like to do the hand, yeah. But it's the same business.
Yeah, yeah, it's the same business. The inverse square law is all over the place. And as I stated, you know, the hand argument creates a very good example that this is an optical illusion that only has to do with the fact that we're looking at the world through a little tiny pupil. And if we actually looked at the world with giant photographic film, okay, that wouldn't happen.
Distance. So that's how you demonstrate Lesage is an inverse square law. But you're missing something. I'm missing something. You're missing. You're explaining this phenomena, but you're not. For me to buy into it that it's potentially a solution, I have to see the numbers. That it's not just a story. That I want to understand why exactly. If this is at zero speed and this hits it, that this sets off at the same speed this is, and we.
Well, again, I'm not saying they do. I'm just saying there's obviously a conservation of the force, the pressure. So how you divide up the pressure, I'm just saying you can understand that if I come in with a 1 and I come in with a 3, that's almost like a charge argument, okay? You know, and that all that's going to happen in the math is that that's going to add up to 4. And you have 4 amount of pressure now, and it's either going to be 2 and 2 or it's going to be some other numbers, but who cares? You know you're only going to get out what you put in, and what you put in, you're essentially doing the math by doing the experiment. The experiment does the math for you. It takes a 1 momentum, it takes a 4 momentum, and it smashes them towards each other, and the equal sign is right here, right in front of you. The pressure created here is going to be 4. It's doing the math for you. It creates a 4 pressure here. There's 3 pressure in the atom, there's 1 pressure in this atom, and there's 4 pressure between the two. And all you know that's going to happen is the 4 pressure is going to be spread over those 2 objects, and either they're going to become 2 and 2, or they're going to become some variation that's going to add up to 4, because you already added up the total here. Right between these two is the total pressure, and that pressure is just going to be divided between these 2 things. I argue equally divided, but you can argue anything you want.
Mechanical sense don't get to say, oh, well, it's just conservation, because we're looking to explain why we see the conservation of these abstract numbers, yeah, like velocity.
Well, I stated before, the reason why is every ping pong ball has to be accounted for, so you can't lose any of them anywhere. And the way they're moving is moving from high pressure by jumping in a boat and then jumping out of the boat into another boat and then jumping into another boat and then jumping into another boat. And that's how the pressure is being spread. So you can just say there's 8 million people here and they're very crowded, and they start running that way and they start running that way. And eventually there's not going to be 8 million people here anymore. There's going to be 4 million here, and there'll be 4 million over here and 4 million over there.
Similarly. And so to prove the idea, the basic principles, I have to be able to say, okay, can we explain this is now going 2 meters per second this way, this is going to catch it up at 5 meters per second, what's going to happen? Yeah? Or this, maybe electrons are of different size, this is twice the volume as this electron, and this electron is 1 meter.
Well, let me just say explicitly again, I don't think they're of different sizes. They're of the same exact mechanical properties, and all you're doing is changing the driver and the passengers, and that's it. You're just changing what they're carrying. And if they carry something different, then they have a different movement through space, and that's all that changes. All right? And when they meet, the force they emit will be an expression of their character, and their two characters will be affected by the adding of their force effects, and they will leave differently than they arrived. Doing the math. They'll do the math and leave appropriately.
And this is, and to actually be sure that this all works out, you have to crunch the numbers and not just say, oh, everybody climbs across. How are as you would put it, the question is how are the right numbers of rowers?
Well, the right numbers are apparent in what we already know to be the numbers. So again, I could argue that the reason why electricity moves a little bit slower than the speed of light is because their jumping is at the speed of light, but the boat moving is at a much slower speed. And that's what's killing the speed of the force moving, is the fact that it has to sit in the boat for a little while, and that's slowing it down. So I've given you arguments that explain why the transmission speed of light through glass is slower, or why electricity doesn't quite move the speed of light, even though the force is moving the speed of light. I mean, those explanations are right there. They're already in the math. They're already in what we know.
Orchestrated, managed, team leadered or whatever, to go from this electron to the other electron. How is it accidentally too many rowers don't go over and it goes too fast? Or this one goes,
Well, it's kind of an orderly procedure, as much as it's, only a zillion of it happening every millisecond. But, I mean, clearly, the guy jumps into the water, swims to the other boat, okay, jumps in the boat. And the rule is every time he jumps in the boat, somebody else has to jump out of the boat, okay? And so what's so difficult to understand? And usually the guy you're replacing is going in the opposite direction you are. The guy paddling this way is going to be in the front of the boat paddling. So I'm going to be replacing him, and then I'm going to run to the back of the boat, and then I'm going to jump into the front of another boat, and then I'll jump, But I'm just saying that there's clear rules. I already kind of defined the rules for you, okay? That, yeah, most of these interactions are up for down, left for right, forward for back. And then in the special case of the exchange, it's actually two. See, this is, I'll confuse you because I'm gonna take it a tiny step higher. But the red-black interaction, when you're doing the red force on the black electron, what's really happening is you have two interactions, right? You have an exchange where a guy jumps in the boat, and then there's another exchange inside the boat, and then they jump out of the boat. So it's a little bit more complicated because there's two moves. There's a move inside the boat, and then there's a move out of the boat. So that, too complicated now.
Yeah. That's the kind of nagging questions I have about this business.
So it's this business. I mean, I'm just saying that you know, if you're going to give me nagging questions about such tiny little, you know, just tiny minutia about little tiny bits of momentum and inertia and equilibrium, when conventional physics has gigantic gaps. They have no energy force for magnetism. They have no energy force for gravity. Nothing. No clue where it comes from. No clue how to give it back. That's why they're borrowing from a vacuum. I mean, please. You know, you're just saying. I'm just saying that you're accepting theirs because of it's crowd pleasing. Okay, the morons ate it. The morons ate religion as an excuse, as a belief system. I'm giving you a pretty good Darwin explanation of evolution. And you're sitting here and resisting it and saying, well, that all sounds too scientific or something. You put too many details in there. There's no Holy Ghost. Where's the Holy Ghost? Where's the dragons? Where's the giants? Where's giants? There should be giants. Where's the dragons? I mean, you know, you don't talk in tongues. How can any theory work if you don't talk in tongues? I mean, you're imposing on my theory a bunch of their jargon and nonsense and saying somehow I'm broken because I don't have 3 bears in my story. Where's your 3 bears? Yeah, I don't have any. Sorry. No 3 bears. But don't you see how your judgment seems completely canted in a crooked direction where you've accepted all their nonsense and you're sitting here nitpicking about, well, how come there's no missing links? You know, how come dinosaurs were too heavy? You know, you're making these superficial critiques almost.
And again, I'd ask to consider what it exactly means for that electron to be moving.
Well, that's the point I got to. It exactly means is that it has a stored amount of seats in its boat. It possesses some amount of energy already, but it's held, it's in seats, and you have to exchange it through the right process.
Is it? I like this idea. I think this is your idea, this sort of rowing idea that the aggregate, you know, let's say you're like real people and zombies, like you said, you know, like you could imagine, you could say they're of different sizes. You could say everybody, depending on the size of electron, sticks out a leg or takes one oar when it gets to a certain point, yeah? And electrons of different sizes then could go different speeds, because the smaller one maybe, but it all has to be worked out quantitatively as a hypothesis to pan out. Would the more oars in the bigger thing mean it necessarily goes faster, or would the less oars in the smaller thing mean it could go faster because they were getting to stick it in the water, so to speak, more often?
Well, it means that they would get out of balance too quickly. So that's the key that would break it. They would go the speed of light too quickly. Too little energy could give them too much speed. So that would be my argument why we don't see that. So that's my only argument. My only argument is if electrons could move that fast, then electricity in a wire wouldn't slow down, and there wouldn't be a slowdown in the transmission of light through glass. You know, those kind of arguments would kind of fall apart if electrons could move light speed instantaneously, you know, that quickly. Getting hit by just a couple of photons, they're going the speed of light. So there has to be something that's slowing them down. And so we're back to the school of fish argument, that they have a bunch of fish going in the wrong direction. So the school can't go any faster than its slowest. The thing is dragging with it, okay? It can only go as fast as the group speed. It can't go the individual fish speed. It has to go the group speed. So the average of the group is its speed. So it has to have a cushion, and I think that adds up to the idea that it is very quantized, So I would argue that there's every reason to believe the electrons are a standard elemental, a standard boat. Okay, and there's no big boat, little boat. There's just one standard boat, and the quanta is how you make the standard quanta of a photon.
If everything's the same size, that seems most problematic. So that's one possibility, that they all actually contribute in a time period, or there could be a case of as you wording you used about real people and zombies. The zombies are useless, and they're not contributing. So, but in the Lesage theory and the polarized theory, that idea has to be taken account and explained more thoroughly. So that prompts the question, as if we're going to use that analogy, that not everybody's having a go at Orin, how is that orchestrated is the point of the question. How come it doesn't get mucked up?
They're all Oring, and the point is that the electron will stop if the field stops. So if the atmosphere around it, the swimmers, balance, the electron will balance. It will give up its imbalance to the environment. But if there is imbalance, it will remain a moving boat.
Too many good guys go over to the other boat. How is it not mucked up that even though this is going faster, that the zombies don't climb over to the next boat? To use your metaphors. Well,
let's just use the zombies as an example. That there's this force, the zombies, who are trying to neutralize everything to zombie. Okay. And the only thing that makes them not effective is that you have to have continuous force. You have to keep pushing the voltage. You have to keep pushing the electron with voltage to keep it going. You have to, everything's going to be drained by the system, by what you could call drag. Again, I don't want to make these drag arguments all over the place, because that's a higher level, because the only way you can defeat the drag is to understand the polarization argument.
Just troublesome. And I appreciate you taking the time, and I don't mean to be to frustrate you. I'd much rather myself read. You get back on board with the writing business, and when you find the principle, thoroughly write that up, and I read it, and I'd make a video reply to the written stuff. That would maybe be my preference.
Yeah, I know, and it's not my preference only because writing is so explicit. I mean, clearly I haven't had 1 million people and 100 years to get all this jargon all perfect. And so I sort of need a little more time to maybe say more than one analogy, maybe to say it a little bit, to add a few extra words, to make sure I'm not being misunderstood. And, it's hard to do that in writing, to make sure you didn't leave the wrong impression by saying something explicit. I mean, even saying something as simple as, I reflect the environment, but I also am a reflection of my history, right? So now I'm going to confuse the point by saying, no, I am a mirror. But wait, no, I'm a mirror that's warped by my history, that has bends and twists in it. And so I'm going to reflect the world based on my previous history. And yes, the world is trying to make my mirror very smooth. Okay, it's trying to make me a reflection of the world now. All right, and so that's the competition here, is how do I retain my history in a world that's trying to smooth it out, to rub it out. And that's the struggle the electron has, sort of. It has a history. It came from a place. It gained momentum. It's like the Earth sitting here in this solar system. It had a history. Its momentum, its velocity came from an event. And right now, what's it doing? It's stuck in a circle, you know.
So that's largely the difficulty in you know, in the communication, on the communication front. So I'm sorry for the frustration. It's and you lost your temper.
I can see. Look, yeah, I'm going to just go crazy just because, like I said, I still am saying, you know, you're just sounding a little bit too much like some Muslim who's just saying, you know, I ain't related to no Minky. You know, it's just like, well, what are you arguing here? Are you arguing the monkey doesn't fit? You know, it's a glove fits perfectly. I mean, you know, it's fingerprints, you know, it's the lines, everything. It fits. And you're just giving me such a fucking, you know, here you are soliciting the trolls saying, okay, trolls, come on out and talk about how Gary's idea is incomprehensible and how we can't understand it. I mean, of course I'm going to get angry because that's ludicrous. I mean, it's so much more understandable than virtual photon.
Don't forget, I'm not endorsing anybody or anything. I'm not endorsing orthodox physics. I'm not saying I believe. I'm just saying orthodox physics says about that. I think you fell out with me over the mass thing about photons don't have mass. That is the orthodox point of view. That mass is.
Well, I know, but we know it's not their point of view. That's the whole point, right? They say they're particle physicists, but we know they're not. They're wave physicists. So let's not. Why are we allowing them to say this crap? We absolutely know they don't think photons are massless because obviously they think they're moved by gravity. And obviously they know they impose momentum. They're not stupid. They know that a laser beam can burn a hole through things. They know it's full of momentum.
Abstract number. And photons don't have mass. They don't so-called interact with the Higgs field. Yeah.
So again, they do have mass. It's just nonsense. They concede it. All they're doing is trying to say because it's going the speed of light, its mass has been reduced to nothing by some weirdo inverted speed theorem. Some special case for just photons, right? Where everything else gets heavier as it goes faster, somehow photons get lighter as they go faster.
So, same again. See if we can't have one more go at it.
I have no choice. So, you know, there's nobody else that's even coming close to making any kind of rational argument. So I don't have any options here for attempting the conversation. So yes, you win by default. But yeah, I'm going to say you do trigger, okay? Your rhetoric is full of triggers. And I don't think they need to be there. I don't think you need to make your point about some fine grain by talking as if it's a catastrophic flaw or something. Like it's somehow some flaw maybe in just your understanding and not a flaw that I haven't, you know, well supported, that I haven't built a nice little Roman arch and done all my work correctly. No, you're just not getting it. Okay, fine. But let's not imply that somehow you have unveiled a huge defect of which is catastrophic to the entire theory.
I'm just wondering whether I don't really have time. I'd like to maybe at one point help you out with the maths on that. Because I think it really needs that amount.
So, well, look, the only way you're going to be able to help out on the maths is, like I said, is the Maxwell equations, in my opinion, are clearly flawed in the sense that they've bisected something that should be consected. All right, it's one force. It shouldn't be bisected. They should just understand the difference between dipole math and monopole math, and that's all there really is. And clearly, this gets into this idea of getting an accurate description of the exact understanding the momentum numbers, all right, understanding what an exact quanta of energy is. And clearly the problem with that is, as we know, is the fact that we measure photons as this ambiguous amount of stuff, right? They're measuring photons by saying frequency at time. They're not saying quanta at location. So this is where it breaks down a little bit. You have to understand, right? Because their definition of a quanta is a time of an amount of time, not an amount of stuff.
Mechanical explanation, explaining the maths we see. That's what we're looking for. And
well, I'm just saying most of the math, everything I'm talking about is quite consistent with, because it all basically does have conservation in it. So the only math that breaks down, again, is their exchanged math. Math where they give photons twice the effective by gravity, or math talking about borrowing from the vacuum. All that crap is where it breaks down.
to the metaphors of rowers, what's the guy called? Is it a cox? Cox, that's the coxet is the bone at the base of the spine. But I think he's the cox or something. But the head of a rowing, the university rowing races. But the analogy of rowers lends me to think, well, who's telling the rowers what to do? How does it all pan out? Okay, how come it doesn't all go wrong sometimes?
Right. Well, that's because the rowers are just, as I sort of say, they're just saying row, 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 one direction. That's all they know. So you trap them, they're just rowing in one direction, and then, as I sort of pointed out, you really, when you exchange, you're making something else row the other direction. This guy you let loose, and he's rowing back in the universe again. So you never really bend energy, okay? I mean, on the fundamental level. You're really just exchanging the black and the red and all that kind of crap, so it does get a little bit complicated. But I'm just saying that that's what really is happening, is the rowers don't really change direction, they just change color. You're just changing their shirts.
That's the thing. We'll see. I hear you, and I fear it, may be the end of me if I don't get justice in this world.
I would just argue that I had the same expectation. You're just saying, look, it's unacceptable to live in a world where there's no accountability. And I kind of had this perception because I read a lot of old court cases, especially Supreme Court cases. And these guys were brilliant. I mean, even when they were defending slavery, they did it in a brilliant way. I mean, they're just brilliant writers. And you're saying, yeah, this legal system has some integrity. But I didn't think about over the last 100 years, all they've done is let political hacks on the courts. So all they've done is put people on the courts who did a political party guy a favor. So if you did if your wife worked for a senator, you got on the court. This kind of bullshit. And so it was completely corrupt. You weren't putting people on the court because they understood the law and they had some devotion to the law. The lawyers became more and more shysters, okay? They made justifications. I'm supposed to defend murderers. No, you're supposed to defend the truth. See, they lost their understanding. They said, I'm an advocate for the murderer. No, you're supposed to be an advocate for the truth. And that's what they lost. And so the shysters became the judges. And, there is no, like I said, you want to find a dishonorable man in your country or my country, you'll find him sitting on that bench. Those are the biggest pieces of scum walking the earth. They're worse than the crooked cops. Because look, even the cops, right? We know there's no good cops if the good cops let the bad cops be bad. If the good cops cover up their drunk driving buddies and their wife beating buddies and they let their buddies break the fucking law, they're not good cops. They're bad cops. And the judges do the same thing. They watch their comrades fuck people over, overtly violate constitutional rights, wipe out the Constitution entirely, and they let it happen. They don't protest. They don't do a Serpico. They don't fight. Okay? They let it be shit. So they're obviously just as corrupt and rotten as the rotten pestilence they're allowing to take over the country. So I'm just saying, if you have an expectation that one of these judges has any honor or integrity, you are mistaken. All right, enough of a video, I think. So on to the next adventure in physics fun. Which really means the next adventure in talking to lunatic, fanatic, religious kooks. Because that's what physics is, a frickin' crazy religion. And it really is crazy, and it really is a religion. It's as three-bear bullshit as it could get.